free will as you think.
Okay.
Like,
I'm just saying.
mind you, it was a
If
simple,
you
it was a
talk to
simple
your
1 to
parent,
10
if you
answer.
really wanted to go to the play, and you're like, Mom and Dad, I really want to go to this play, but I don't want to miss my AP Stats class because I really need to be in class to learn, I think they would manage to get you there.
No, my mom don't even manage to give me places I need to go.
Sorry.
Mind you, you could just answer 1 to 10. Like, I'm like, this is all necessary.
So,
10.
I see that now.
here's the thing. I'm not going to be mad. It's your choice. I'm saying you should probably be here.
I guess I'll consider it.
So, what questions do we have off of, do we manage to get a chance to look at these? Get down our answers that we need to?
Wait, so for number 4, I said that like Michigan had more public colleges, but I said relative to their like groups. Like, does that make sense?
Let me go pull up the data and then yes, we'll look at that. So,
Well, I mean, you just need a Z-score, because I'm just saying like it has.
yeah, has its, oh, I see what you're saying. So it has a Z-score of 0.267 for
Yeah.
public colleges, 0.228 for private colleges. But that just tells us, again, it's a no because we just know that they have more public colleges in respect to the average number of public colleges for the entire country. And that just means that they have more private colleges than the average number of private colleges for the entire country. But it doesn't tell me about those two different distributions.
Well, I mean like. Oh, okay. So that's just talking about like the average for the whole like the. Okay.
That's just saying, yeah, that's saying that Michigan's number of public colleges is 0.267 standard deviations above the average number. And their number of private colleges is 0.228 standard deviations above the average number of private colleges. Those are two very different distributions though, so we don't know if they have more public or private.
Yeah. So that's why I just wrote like relative to their
Right.
groups.
That's the idea of Z-scores heavily is that it's how many standard deviations away, above or below the mean for your group, but those are different distributions, so we can't directly compare the number for each. So that's a good question.
So,
Go for it.
17 is for the total number of public colleges, right?
Utah has 17 public colleges, correct? Because yeah, it's based on the 17 that was up here, and so value minus the mean divided by the standard deviation.
I'm trying to.
Huh?
You wrote this?
No!
I can tell.
Yeah, no!
Did you write this?
No,
Oh, who wrote this?
I don't know.
the mathematic lady.
It's neat, but it's also human.
Yeah, it's like very like,
It's
Legible.
like too perfect.
It's pleasing to the eye.
yeah.
But it's obviously like it looks like it's a computer, but it's also like.
So getting back to the statistics, okay.
It's like
What stats related questions do we have?
So it's the total minus the mean divided by the standard deviation.
Well, not the total, well, it is the value minus the mean, right? Divided by the standard deviation. Remember yesterday how we looked at how far the number is from the mean?
Mhm.
Then we divided it by the standard deviation to know how many standard deviations it was. It's that idea. So make sure you have that formula down. You've got to know that formula. Value minus mean divided by standard deviation. And this is a more generalized form that can work in a few different cases that we'll look at later this year. So value minus mean divided by standard deviation. And again, it's just where your score is relative to everybody else's in standard deviations. Yeah,
What unit is like the most math heavy unit?
next unit.
Next unit?
Next unit
What
is
about after that?
probability.
Oh my god.
It's not terrible, the probability. There's certain rules we'll learn that will help a lot, and you'll learn the probability a lot better. After that, it's applying a lot of the probability, but it's not super mathy. It
it's
involves
formulas.
math.
Which is more mainly formulas.
There's formulas-ish, and it's interpreting what the numbers mean. It's a lot of interpreting what the numbers mean. Okay,
Okay.
no more questions on this? Do you notice, like, if you're working on 2 and 3, it's just taking this formula, right? And substituting what you have in. So like with this one, the mean and median, or the mean and standard deviation did not change, but you knew your number of standard deviations, so you solve for x. Right? You use your inverses to solve that equation. Okay? Here, you just had to simplify. Make sure you understand how to solve that equation. So we all good on that? Alright, we are going to continue with the mathematics stuff, try to get up and active with things. Apparently I forgot to delete this slide.
Well, have you graded our thing?
What thing?
The checklist thing.
Nope. I got the last demonstrating understanding check graded. It's a whole thing. My wife and son have the flu, so we're trying to work through all that.
Oh my goodness.
Yeah, it's a time. Alright.
I'm not praying on your downfall, but in case you fall sick and have to go home.
If I catch a sickness, it's gonna be after class tomorrow.
He's gonna post a video anyways, be so.
Yes,
And
Brandon.
then during the weekend, he's gonna like redo
He's
all
gonna
of
make
I-
it
it.
go
same
into
dude.
call.
Straight up, I have no clue. I'm not sure.
If you
God
get sick,
forbid.
if you get sick, would you just do like the lessons online?
God forbid
Sit
the
like
It's gonna make us
Guys,
go to-
I'm here for a
She
reason.
should teach us. She should teach us.
Yes.
Brandon's like, I've never seen you in my life.
gym with us.
What is this?
You can come to the gym.
I
No, they only go to the gym. She's got a sub
I
license.
took notes. This is how it
Really?
works.
Yeah.
To be honest, I thought she had
Okay.
a license for real.
It's just,
So,
I think I.
I do need y'all to hear me on this really quickly. So we're about to jump into where we left off yesterday, but today is all about understanding how transforming data can create the standard normal distribution and how we can use those z-scores that we discovered yesterday when the empirical rule fails us. Because the empirical rule we ended yesterday only works when we have what?
Integer back,
It has to be normal distribution, but so it is for what we're about to do today.
like integers, what?
The integer number of standard deviations. So remember, it only works from -1 to 1, -2 to 2, and -3 to 3. If it's something outside of those integers, we've got to use something else, and that's what today is all about. All right. So we looked at this yesterday. I gave y'all the answers for 2 through 4 as part of like a practice for the empirical rule. Did y'all finish working through those 2 through 4 to see if you had any questions?
okay, what's
It's this one. Yeah.
is this page before the rest of it?
Yeah. Well, it's after.
It's after the one we just looked at.
Yeah.
Is there through here?
Mom. I don't know.
Me?
I thought I saw it.
Oh.
I'm trying to find it.
How about, I think you're looking at, I don't know.
Ms. Wolski, do you remember where this went when you made
I got
copies
like this
yesterday?
thing.
Did you pass it out?
No,
I thought I was thinking, okay, so.
That was over here.
I got it.
Put it, I think it's on the bottom of this.
So where does this go?
So here's some stuff that goes along with the empirical
That's
rule
separate,
for
I think.
those.
That's like a different paper you gave
Are
us.
those-
What?
That's not in the packet, but you gave us the visual, right?
No, that was packet.
So we're going right
It
here.
goes-
Ah,
yeah, listen, it's lesson 2.2.
That's 2.1.
Yeah.
Okay.
Hey, so.
I was just going based off what you gave me.
So this goes with the empirical rule
Trying to
stuff.
crucify me.
If you wanted more practice with the empirical rule stuff,
We'll be
I will
separate.
provide solutions at some point so you can check it if you need it. Yeah.
No, I actually know this.
I figured. So if you want more practice with empirical rule-based ideas, this will get you there. Does everybody have one now? So this is Sprig, Jaden, and Serena. All right. So once again, remember, and I just want to show you all this really quickly. You can use z-scores with these kinds of ideas. You just don't have to. So for instance, the value here is what? 246. So remember, value minus mean divided by standard deviation. So 246 minus
220.
220, all divided by 26.
Yes, 26.
So notice that is 26 divided by 26, which is 1, which is exactly what we do. 246 is what? 1 standard deviation above the mean. Really, if we want more context with it, right? Like a song that is 246 seconds, notice I start with context. A song that is 246 seconds long is 1 standard deviation above the mean. That's it. And so the empirical rule works as long as we have an integer number of standard deviations. As soon as you get to
Please
something
have
like,
Jamin back to the office really quickly.
he is in the theater for the play.
Thank you.
When you get to something like number 5, when we look at the value, 181 minus the mean, divided by the standard deviation, was it negative 39, I think? So z is negative 1.5. And so remember, and I talked about this yesterday, I need you to hold on to this. The reason why why were we able to do like half of 68 to get this right here?
Because you can just.
The 68 is moving.
But why could we just do half of 68 to get this as 34?
Because we knew the, like.
There's something here, it starts with an S.
Symmetry.
Remember, there's symmetry, right? So what do we know about this piece and this piece? They are, they're what?
Equal.
They're equal, they're the same, right? So this is only half, and I could use half, right? But all of a sudden, when I start looking at 1.5, right here, is this piece and this piece the same? So I can't use halves within the empirical rule, or even parts. That's why I can only use integer standard deviation. So we need to go back somewhere. We need to work with something to help make our life easier, okay? So we're going to come back to this lesson in a second. This is what we're going to be working with. And so it should be just the next little activity in the packet for mathematics. Huh? Yeah, because remember that was 34. And so 50 minus the 34 we didn't want meant this was 16%.
Okay.
I was just making a point about yeah. But we need to sit down and look at that. This is why I don't want us tomorrow.
Yeah,
All joking aside,
no, I won't.
you missed.
I was jumping on ass.
Yeah.
I was.
Sure.
I'm not gonna waste $7. You know what I can get with $7? A biggie bag.
You're real.
What the
Real
heck's a
for that.
biggie bag?
Biggie bag
I don't go to Wendy's,
That's the problem.
What do
now.
you eat? Do you eat fast food?
Chick-fil-A. Every now and then I get a hankering for Taco Bell.
I don't like that.
Serious.
Taco Casa is better.
Ew,
That's about it.
Taco Casa is
Taco
uniform
Casa is
meat.
better.
Taco
Please
Casa
don't
is
overlook
uniform
Actually
meat.
enjoy the munchies.
Whatever.
One, yes, but two,
They are
like
better.
this is
They are
bougie.
better.
So listen, I recognize this is a little bougie, but if I'm gonna eat out, why am I gonna do fast food when I could just stop by Pastor's Kitchen and get some quality Mexican, or pick up Lost Pizza Company, which is some quality pizza, or Tuscany Pizza, which is some
Do
quality
not make
pizza.
me
Yeah, that's
hungry.
Okay.
See how the words
Tuscany,
go off your
right?
privileged tongue?
Okay, so like listen, I'm bougie when it comes to food. I like to eat, so I either cook
Oh my
well
God.
or I eat good food.
What do you cook?
There's nothing wrong with it.
What else? What if I'm feeling
There's a lot. I don't have all day.
It's trash.
My
No,
favorite
Taco
thing that I
Casa is
make,
so good.
a Philly cheesesteak sandwich. I have a Blackstone griddle and I cook on
Okay,
it.
whatever.
Anyways, all right, getting back to this, okay? Sorry,
Wait, Miss
I got distracted by my food.
I have a
Huh?
question real quick. I'm sorry to interrupt. Have you had Taco Casa before?
Yeah, it's disgusting.
Thank you.
No,
I
okay,
get
you guys don't get it. You guys don't get it.
He is Michigan. It's disgusting.
Listen,
Taco
like-
Casa.
Listen, I understand you grew up in Tuscaloosa, and I understand that your taste buds are broken.
Oh my God.
However,
I've lived in
I didn't grow up in
No,
Tuscaloosa.
I moved to Tuscaloosa to have Taco Casa never again.
I lived in Vietnam
Never.
for
That is
5 years.
rubbish.
Be self-real.
It's just whitewashed Mexican food.
It's
It
terrible.
doesn't matter what it is. It's disgusting.
Alright, right here though, stats, okay. So we're going to learn about what happens to distributions, because here's what I want y'all to recognize. What we were just looking at in the last context was a normal distribution of songs, right? And what was the average, 220?
Yeah.
And the standard deviation I think was 26 seconds. So this is the distribution that we were dealing with. But man, it'd be nice if we could make our lives a little bit easier. And that's what we're going to learn about. Okay, so right here, we have a set of test scores right here. And so your teacher is considering two options for bumping up the test scores for Unit 1. But how would this affect the distribution of scores? So here's an option. What are you going to do to those scores? At 5. Now, we want to compare these two distributions. We're going to draw it out, sure. But what could help us assess the shape, center, and variability when adding 5?
It's gonna shift everything.
Say it again. calculator, guys. If I were y'all, I would definitely make sure I have a calculator. I want to show y'all one quick tip with this calculator.
Okay, but it's easy math, you just add 5 to everything.
You just shift everything.
Yeah.
Hey,
you just
guys.
move everything to 5.
Guys, do you want to learn how to use these calculators for the AP exam?
Well,
Yes?
you can just do it straight, it's not difficult.
Mike, we take calculator?
What if we want to use a
I got one.
calculator?
But let me show you this really quickly, okay?
Y'all need to add.
You don't need to use the hat right now. Let me just show you this. So, I'm going to put the variable scores here. You can put whatever you want. But, what was the first score?
60.
And then
65.
65, then
65.
2 65s?
Yes.
And then?
75.
Alright, I'm going to pause here. I just want y'all to see this. This is going to help us see the same idea just as quickly. And yes, you're going to add 5. The point I'm trying to make is to understand the center and the spread, because that's where things get funky. So what I can do is I can hit equals, and I can put the variable scores and just put +5. So if you go to that equal sign right here, you type in your variable scores +5, notice how it automatically adds 5 to all of those. What was the next score again?
75.
After 7, was it 2 75s?
Yes.
Watch what happens when I put 75 here. It automatically updates it for me.
I like
Okay.
that, I like that.
I know, I know.
Do it, that's so
Technology, baby, that's what I'm all about. So,
Okay.
You know which Illuminati, so.
definitely, yes, fill in the +5 there. The point of the calculator is to help make your life easier for the measures of spread and center. Okay?
So go ahead and put them into the chart.
So go ahead and put them into the chart. Yeah, add them here. Go ahead and graph. So I will say this. Graph your dot plot by hand. Put your, and before you do the calculations, let's make a prediction in a second. Yes, Lana?
Oh, never mind, I got it. I'll show you how to add the page.
Oh, gotcha. So, well, hold on, that's a scratch pad. So, you can do new for a new document. That's my recommendation. You don't ever need to save it unless it's a named thing. And so remember, you want lists and spreadsheets.
Can we expand the...
And make sure you name the variable. Say again, sir?
Can we expand like this? 'Cause,
Mhm.
yeah,
Yeah, it's a beautiful graph. Can I borrow that real quick?
sure.
Thank you. Okay, so. Is it 480s or 34?
4.
Thanks.
Mhm.
You're the best, Michael.
I know, right?
Right, right.
Say again.
What do you want to do after that?
So, have you drawn your dot plot?
Oh,
I'm not really.
Oops. I thought you said to make a prediction before.
Well, draw your dot plot. Well, actually, that's good. Yeah. So let's pause. What do you think is going to happen to our graph? What do you think might happen to the shape?
Everything's the same.
So the shape is going to stay the same. It's just going to shift to the
Right.
right. Okay. So what do we think that means in respect to the measure of center?
It increases, but like the overall, like
It increases
the
by
median and the mean increase.
So the mean and median should increase by 5. Okay. What do you think is going to happen to the spread?
It
Stays the
not-
same.
it stays the same.
It's going to stay exactly the same. Nothing's going to happen to that spread.
Should it?
Well, when you word it like that.
Well, shape would stay the same, but like,
I mean,
It's gonna be
what do you
different.
guys, like, what?
So this, I mean, I'm just asking. Like, we're going to have different numbers, right? So is the spread going to change?
I mean, like the range is gonna
Well-
stay the same,
Why do you think the range is going to stay the same?
because it's like the same,
It's the same.
Actually, the spread
same
would
distance
change.
between
Well-
the max and the min.
So I was like, just looking at the max and the min, originally our minimum was 60, now it's what?
65.
It was 99 for the max and now it's 104.
So it,
Did the range change at all?
No.
So when we add like that, what we're predicting is that the shape is going to stay exactly the same. All the data points are 5 up, so the mean and median are going to be 5 more, and the spread will stay the same. That's our prediction. All right.
Yeah.
So let's graph that data, and let's look at the mean and stuff like that. We What I will say is this, you run the, one variable stats for the scores on your calculator to get practice with it, I'll do it with the +5. Okay, so you run the one variable stats on your calculator with the scores.
You can scores. I think you should do it this year, you put a box.
Where's your list of spreadsheets go? Nope, not right there.
There's two documents.
Here.
Okay.
But the other issue is you haven't actually named this variable yet. Wait, where did you get those numbers?
Oh, I just made them up. I just want to see how to do it.
Oh.
No, I already got all of these, so I just want to see
Okay.
how they actually do it.
So make sure you name it.
You got no time?
Huh?
Yeah.
You wanna keep putting it in so you get some practice with it. But when you did the one variable stats for the scores, what was the mean?
Actually get something done.
What was your mean for one variable stats for the scores?
80.
80.
80. What is mine?
80.
So exactly 5 more, just like we expected.
Oh
What's, you got 80, didn't you?
Yeah, I understood. It's like I forgot you did it for the.
I did it for the +5, right. What was y'all's standard deviation? 9.989?
Yeah.
So if we add everything by the same amount, is that gonna change my spread at all?
No.
No, okay. So let's scroll down a little bit, let's check some of these lower ones. What about my minimum or what about my 5-number summary compared to yours?
It was
Same thing.
increased.
+5.
Yeah, do it.
Are all of mine 5 more than yours
Yeah.
for the 5-number summary?
Precisely.
Precisely, right? I do want to point out something I just noticed. Man, that median for me is also 85. Why am I pointing out the fact that my median is also 85?
Your median 6? No.
Well,
Might change.
the median definitely changed. My median, your median's 80, right?
Yeah. It's,
Mine's 85.
it went up exactly 5.
Yeah, but there's something else that's really interesting about that
Was it
from earlier. I feel like I saw 85 somewhere else.
The mean?
The mean was also 85. Why am I pointing that out?
Because it's symmetric.
Oh,
It's symmetric.
Oh, that's right. Look at that graph. Is
Oh,
that
it
graph pretty
symmetric.
symmetrical?
I forgot.
Not really.
Yeah. Debatable.
Not really. Looks funny.
Like, I don't like the values. It doesn't make it look.
There you go.
Notice it. Here's the thing. Like,
how it looks.
It's
listen.
very
Okay, let me,
Yeah.
guys.
It's flat.
I was saying, right here. If I were to draw a density curve over this thing,
Oh,
It's kind of.
Yeah, there's like
Wobbly.
one point out.
It's kind of
Just like,
wobbly.
you know.
that looks pretty similar on both sides, doesn't it? Did I ever say
No.
it's perfectly symmetrical? No. What do we always say in stats? It's
Roughly.
roughly or approximately, right? We don't say anything is symmetrical because nothing's perfect. But come on, geez. All right, so IQR. My IQR is 8.5. What's y'all's IQR?
Or
8.5.
It should be 8.
It should be 8.5. Is it 8.5?
Yes.
Yes, okay. So it's important to recognize, right? So what do we pick up out of this? When we add or subtract, it changes the measure of center, but what does it do to the shape and the spread?
It does not
It
change
It
that.
doesn't change, it stays the same, okay? So adding, and I will say this, adding and subtracting will change the measure of center by that much, but shape and spread stay the same. Okay? Now that does mean we have to do it to every data point.
I'm hungry now.
what did you say, add, subtract?
So adding
I'm
slash
gonna get taco
subtracting
pasta tonight. I'm getting
changes
taco pasta tonight. Just like
I mean, you can punch yourself if you
you
want.
guys are haters.
You need to leave.
like you see, I used to like Taco Bell more.
You guys are
Or
haters.
Taco Pasta more than Taco
What-
Bell.
what
Then I
is the
realized
thing that-
Taco Bell had nacho
Thank you.
fries.
There's
and
nothing that
everything.
hate on, I'm sure.
I mean,
Taco Pasta can't.
What is it,
There's
what
not
is
a
it
fries.
cheese that's so good? What's up?
It's 2 steak and
It's
Like
eggs.
after a
Everybody
football
makes
game,
good.
after a football game, you either go to Taco Casa.
After,
or-
I mean, I'm
that's
not
like,
gonna lie.
that's like
You can't
willingly
eat
suicide, like who wants to
Quesadillas
go
are
there?
really expensive as
Okay.
well.
Because I'm
So-
hungry.
adding and subtracting changes the measure of center by that value, but spread and shape don't change. You know where I can get a really cheap quesadilla? At home, I'm a Blackstone. It's fantastic.
That's
That's
Anyways,
so bougie. Like, you have a black.
I mean, yeah, but
it is
What if-
fantastic.
but what if my mom
No, I'm
doesn't buy this
upset.
stuff?
I've had it for like 2 years. What?
Yeah.
What if my
I'm
mom doesn't
gonna
buy this
go
stuff for? She
I
doesn't
can't
buy
hear you because tonight I said loud. What?
I
This
just
is-
stuff for it. She doesn't buy taco stuff anymore.
Like, you already talked about it.
It's good though.
I mean, it's good. I mean, I agree, it's good, but like,
I'm just gonna.
No one's
It's
that
tough
hungry.
living the ingredients.
Like, you on that Blackstone.
household.
Like, something like-
Alright, so there we go. What happens to shape, center, and variability? Adding or subtracting changes the measure of center by that value, but spread and shape don't change. We need to recognize that. Now, let's talk about a prediction here where we just double our scores. You think your teacher ever is going to double your scores?
Please.
if they were
Or-
very, very nice.
We should do it in
I'm not that
I
nice.
know,
I'll tell you
right?
that right here, right now. I know you already know this, okay? Alright, so what's our prediction? What's going to happen to the shape, center, and variability when those scores are doubled?
The center
Actually,
would stay
one
the
thing
same.
is-
The same thing happens.
The same thing happens, so we're going to double the center, but the shape and spread don't change?
Well, it goes up by
No.
2 each.
No.
Like,
Thing-
it doubles and then each one is 2.
Wouldn't it be like a bigger, like if you double 16, wouldn't that be different than doubling 99?
Well, it's like 2 each time. Like, after the doubling, it'd be plus 2, basically, for each, like, increasing
You add
value.
60, I mean, if you double 60, you add another 60. That's
I mean, so what's our prediction though?
I mean,
What,
it's-
is the measure of center going to change?
Well, it might.
I don't know, it's a-
If I double all those values, what do you think is going to happen to my measure of center?
It probably, I thought it would change, because like if you double 60, you're just adding another 60. If you double 99, you're adding 99. That's different than adding 5 to the one, you're adding different amounts.
Okay, you're correct, but just focusing on measure of center.
Okay.
No.
What do we think is going to happen to the measure of center?
It's to increase it.
It's going to stay the same, it's going to what? Increase it? How much do you think it's going to increase it by, Peter?
2
So it's just going to add 2?
times,
It's going to multiply by 2?
maybe?
Maybe?
Maybe.
No idea.
Not sure?
I mean, I thought it would have.
Because
All by
8
two,
times,
two,
I think-
two,
times
two.
2 is 160, so it's gonna make the center ones.
Okay, so I was saying, like, we originally saw 80 times 2, so like, if I take everything and I double it, you're right, like, that's gonna double, but also this is gonna double, so what's gonna happen to my measure of center? It's going to probably,
Shift right, when everything's.
now be careful, that word shift means something mathematically and statistically. Shifting is the idea of adding and subtracting.
Okay.
When we multiply, that's dilating or spreading something out.
So
So it
the
would
spread
dilate
is
right,
gonna-
creating a left.
I thought it was stretching.
The
and
spread is gonna like
dilating.
increase.
I don't know that I would, so here's the thing, okay, so, but remember, this is why I need y'all to focus on language. I am just asking about the measure of center. What's gonna happen to the measure of center?
It's gonna be 160.
Increase by.
So how did you go from 80 to 160? You
double it.
doubled it. So our prediction is, if we multiply, whatever we multiply by, that's changing our measure of center.
Yes, definitely.
Okay, what about our spread? What do you think is gonna happen to
It's gonna
spread?
increase.
It's gonna increase?
Yes.
Any predictions about how much it's gonna increase?
A lot.
By 2 times.
Maybe times 2 again?
What?
Okay, let's check it out. Okay, so this is actually why I wanted you to create this on the calculator, because watch this. Right now, I'm gonna go into this, and I'm gonna change it from plus 5
Oh,
to
it doubled.
times 2, and yes, it's okay to overwrite, boom. Ew, oh yeah, that's right. So times, and, oh yeah, it did do it.
Yeah.
So, look at my mean there. Did it double?
Yes.
Yeah.
What happened to my standard deviation?
It's.
Roughly double. I mean double.
I would say, it was like a 9.98, you know what I get when I double that 9.98?
Like
19.9789?
something like that.
Mine's don't look, mine's don't.
The range also doubled.
Hold on, y'all don't need to type this in, just look at
I
your
have the
numbers
same
versus
number.
my numbers.
Okay, so it's supposed to be different even though we have the same numbers right here.
Right, but remember, you ran one variable stats for the scores, I did it for this.
Okay.
You did the scores, I did the,
So it's supposed, okay. that's two
Transformation.
times.
okay, yeah. So, did our mean double?
Yeah.
Yes. Did our standard deviation double?
Yeah.
Also, yes.
Also, yes. If I move down through these things, what about my 5 number summaries? Are those all doubled?
Yes.
Yeah. If I look at my IQR is now 17. I think the last time it was 8.5, wasn't it? So what's happening when we multiply?
Double.
Just double.
So multiplying,
Or like multiply by the
You just
number
double
that you
everything.
multiply from.
now I will say, so I want to hold on to that. I do want to remind y'all what's very heavily connected to multiplying is basically a type of multiplication.
Exponents?
Well, exponents are repeated multiplication.
Addition.
So remember over here I did adding or subtracting,
Division.
multiplying and dividing, okay.
Uh,
Did you say that?
No, I was just
Okay.
confused because you said.
It's just similar to.
Yeah, it's like.
Yes, I should have said equivalent to.
Okay.
Division is equivalent to multiplication, right?
Yes.
Multiplying by 1/2 is the same as dividing by 2. You're right.
Because
I
I
should
thought
have
it was
said that.
like a different type.
Yeah,
of
that's
multiplying.
my bad. I screwed up on that one. So multiplying and dividing changes
Oh my gosh.
the center and spread by that factor. And so remember, what we mean by factors are just things that we multiply by. So whatever we're multiplying by, that's what happens to the center and the spread. But the question is still coming about with the shape, right?
Wouldn't it just get stretched?
It would just get stretched, so is it gonna make it skewed or is it gonna still stay roughly symmetrical?
It
It's not
won't
the
be
same, it's
skewed,
just more
it's
spread
just be
out.
like,
It should just be more spread out?
yeah.
I do wanna point out, what's my median here?
160.
160, what was my mean again? 160, so it should be approximately symmetrical, okay?
Is it like the variability?
So add data, so remember, if you wanna ever do a graph with data, you wanna go to data and statistics, not graphs. But let's put times down here. How does that look? Does that look pretty darn similar?
Yeah.
It's just more spread out. You can't even really tell it's more spread out here because it's a different scale. Okay? So how does multiplying and dividing change the shape? Say again? I mean, did the shape change?
Stretches or compress?
Now, pause, I want y'all to recognize something, this is important. When you talk about stretches and compresses, is that shape or is that spread? Look at that. Does that shape look different than what you started with?
Oh,
Sort
spread.
of, kind of.
Right. Talking about stretching and compressing is affecting the spread. It affects the measure of center. But is the shape changed?
Not really.
No. Multiplying and dividing changes the center and spread. Adding and subtracting changes the measure of center. But nothing is changing the shape. Okay? So, adding and subtracting changes the measure of center by that value, right? Spread and shape don't change. Multiplying changes the shape, or changes, sorry, the center and spread.
So does anything change the shape?
No, nothing adding, subtracting, multiplying, and dividing numbers will change the shape.
Can you exponent it?
Roll them just. Wait.
No, we don't exponent.
Okay, but it'd be interesting.
But
What if you did?
what if I want my score to be higher?
Yeah, it'd be so interesting.
It would be so interesting. We don't do that in stats, don't worry about it. Okay, so we're gonna continue with the rest of the stuff they have here in a second. But here's why this is important, what I want y'all to recognize. I want y'all to think about this. When we calculate a z-score, how did we do that? What does z equal? The value.
Minus the mean.
Okay, so I want us to stop right there. So we take a value and we subtract the mean from it. If I come over to here and I subtract the mean by everything, right? So I look at each of these standard deviations, for each of these values. So what was this one? 168 and 142. 298, I think. Okay, so let's say I take away 220 from every single one of these. What's 220 minus 220? 0.
Oh.
What's 194 minus 220? What's 168 minus 220?
Wait.
I promise.
Can't-
And then 142 minus 220 will be, 246 minus 220.
Try to say
26.
52.
And 78. Notice that distribution stays the same exact shape, doesn't it?
Yeah.
but I subtracted everything, every data point by the mean, and so now I have these new sets of numbers. Okay? And then from there, what do I do for my z-score? I take those and I do something to it.
Divided by the standard deviation.
Divide by the standard deviation, right? Okay, and because it's now centered at 0, that's not going to change. What's 0 divided by anything? It's still going to be 0, okay? So sorry for having to erase this, but that's still going to be 0. Hey, what's negative 26 divided by 26? Negative 1. Negative 52 divided by 26. And negative 78.
1, 2, 3.
What we started with is called a normal distribution. There's infinitely many normal distributions in this world, okay? But we can make our life easier by converting it to a standard normal distribution. By subtracting the mean away, I've got it centered now at what? 0. By dividing by my standard deviation, I'm now reducing the spread or changing the spread so that the standard deviation is 1. So, subtract mean to center at 0, divide by standard deviation, divide to make that 1. And so, when I am looking at a distribution, or let's ask this question, what makes something a standard normal distribution? What has to be true? Why is this now a standard normal?
It's in integers.
We had integers to start. So remember, if I have the distribution with these values, it's normal. It's not a standard normal. The distribution with these values, once I subtract the mean away, that's normal, but it's not standard normal. When I get the distribution to here, so essentially think about it like these are no longer here. I am just thinking about it as these. This is now a standard normal distribution. What has to be there for it to be a standard normal distribution?
Like
What is 0?
Like a 0 in the center.
So 0 is the mean. So that it's a normal distribution. With a mean of what? And what else has to be true then? Because remember the step before this had a mean of 0. The step before this had a median of 0 too. What was the last step? The standard deviation of 1. Standard normal distribution is a normal distribution with a mean of 0 and a standard deviation of 1. I said this earlier, there are infinitely many normal distributions in this world, but we can relate them all back to the standard normal distribution. And so we're going to consistently tie everything in statistics back to a standard normal distribution to make our lives easy. That's why z-scores are important. Z-scores identify where we are on the standard normal distribution. And so by understanding these transformations, we have created the standard normal distribution. So we had normal, nothing changed the shape. We shifted the center down to 0, and then we divided by the standard deviation to make that standard deviation 1. Now, let's go ahead and finish probably the back side of that lesson before we go back to the one about song lengths. So, no, you're just there. No. Stay on the lesson that we're on. Move to the back side where it has 3 through 5. I want to do those now. So I want you all to go ahead and talk with each other. And try to calculate that z-score. 2 steps 3 and 4. You got this. I'm going to come around and check in on y'all. Ms. Kowalski will as well. All for being gone.
What?
I'm joking.
They lost.
Oh my gosh. So, big idea summary for those who are just now getting in because I forgot to start the camera.
This isn't a live stream.
It does not matter. It does not matter what distribution you start with. If you standardize that distribution and convert everything to a z-score, the shape that it started as will be the same. The mean will become 0, the standard deviation becomes 1. That makes our life easier. It also makes it easier to compare different distributions, right? That's one of the big things. We will see cases where being able to compare different distributions is really powerful. All right, so I want us to do the check your understanding here. I want to give y'all, I'm going to be honest, 5 to 6 minutes, so I need y'all to work quickly and efficiently, then we'll go over it and get back to the song stuff.
Like the dish, like every month.
What are you talking about?
I asked you
I'm
why
sorry.
each
Should be.
stage,
So remember, in this case, I'll talk about it in just a second, okay? Alright, so, was it 6.11, is that what y'all got when you divided?
Yes, roughly.
Roughly? Approximately?
What does that M mean again?
It's not an M,
Oh,
Mu.
mu, right?
mu, it looks closer to like a U almost, but, like that?
What does it mean?
What does it mean?
Parameter.
It is a parameter.
Parameter mean. The mean of the population.
Mean of the population, right? So, remember, the mean and standard deviation of the population are called parameters. Yeah. If it's a population characteristic, it's called a parameter. Okay. So notice what we did is we just took each of those values, we divided it by 7, right? We went from days to weeks, and the shape stayed the same. Then we came down to here, and everyone got some literature. They started doing it a little bit more regularly, taking a week off the time. So what was the mean now? I guess really I should be using X bar. Is it a sample that we're working with? Yeah, it does say a sample. Why'd you let me use mu?
Because you didn't
Well, you just chose it yourself.
Yeah.
And I thought you were the teacher.
I don't need y'all calling me out like this.
I thought you were the
Okay?
teacher. My bad.
So it was
I
1
thought you were
week
the teacher.
before. It was 1 week before, so it went from 6.11 weeks to 5.11 weeks, and the standard deviation is still 5, right? And the shape stays the same. But if we get down here, and this is again the most important part, let's say we convert everything to z-scores, what's the shape now going to be? Same. By the way, did y'all actually look up here? What is the shape? What would we call that?
Right.
So it'd be, there's something else I would say with it. Unimodal, skewed,
Right.
right, okay, so let's say unimodal and skewed right. And so what are we still going to see? It doesn't have to be normal, it's in this case going to be unimodal and skewed.
Oh, right.
Right, thank you. But now it's going to have a mean of 0 and a standard deviation of. Again, the beauty is when we center at 0, standard deviation of 1, it makes our job easier to compare. When it's a mean of 0, standard deviation of 1, it makes our job easier to compare. One thing I do want to remind you as we're getting some final notes down here is, if we're talking about a normal distribution, roughly how many standard deviations should you have on either side of the mean? 3, right? 3 above, 3 below. If it's not normal, are you going to see that necessarily? No, right? So that's a good hint for us a lot of times. It's like that idea of how many standard deviations do I have? If I got 3 on either side, it's probably normal.
Wait, why would it be 3?
Well, remember this is the standard normal
Oh,
distribution.
okay, wait, yeah, okay. I thought you meant like 3, like between.
No. So 0, 1, 2, 3.
Yeah,
It gets us close to the end. Because remember, what percent of our data is within 3 standard deviations? 99.7%. Okay.
Yeah.
Now, coming back to here. Actually, we need to do the number 5, I guess. I forgot to put that back in here. Okay. So what percent of songs are shorter than 181 seconds? So 2 things I want to show you. I'm first going to show you the way. No, I'll explain it later. I was going to say I'm going to show you the way that I'm never going to use, but it's silly. The tables are silly. We live in the 21st century. You can use what's called a z-score table. Did you have to do z-score tables when you took
Yeah.
stats? They're useless.
Yeah.
Okay. I'm gonna show you how to use a calculator for this, alright? So here's what I want us to do. Remember how I told you how to, if I'm doing one of these problems, what I'm gonna do every time, whether it's empirical rule or not, I'm actually gonna draw my normal distribution, and I'm gonna shade some stuff, okay? So, the other thing is, I will point out this, if you're creating a normal distribution using these seconds, you really have to think through putting the mean and then putting your standard deviations here. But if you convert it to the standard normal distribution, what's your mean always going to be?
0.
And what's your standard deviation always going to be?
1, 2.
So if I'm ever working with normal distributions, I'm always going to convert it to the standard normal distribution every single time. Okay? So what was my z-score here when we converted it before? Does anyone remember?
1.5 below, maybe?
1.5 below, maybe? Okay, let's write it out if we haven't already. Value, so I even broke my rule. So value minus the mean divided by the standard deviation. So 181 minus 220 divided by 26 does come out to be negative 1.5, okay? So I'm going to mark my normal distribution here. Boop. Now, I have that negative 1.5 marked. Which direction should I shade? To the left, to the right? Should I stop somewhere?
Left.
I'm going to shade left. Why left?
It is shorter.
It's got to be shorter, right? Okay, cool. Now, I want to point this out. Technically, normal distributions never stop. Technically. So there really is no bottom to this. Meaning it goes to negative what? Infinity. You know, you can't really deal with negative infinity. But we are going to say that there's a lower bound on this. I'll show you why this matters in a second. Let's say, I will point this out, negative 3 got us to like 99.7% of the data. So like what lower bound do you think would be a good number to say like, okay, it stops shading here?
0.
Well, 0's all the way over here.
Oh, you're talking about the
Pi.
Interesting choice. Maybe a negative pi. I wouldn't go with pi though.
No?
No.
Wait, say the question again?
So like, I need to figure out where it stops shading. Where does it stop shading? What's a value I could use?
Negative 1.
Negative 4 probably. Negative 5. Negative 6. What were you thinking?
Negative infinity.
So negative infinity is ideally what we could do. And if we had the next level up of those calculators, it could do it. Can't do it with these though. So let me point this out again. Remember, what percent was within 3 standard deviations?
99.7.
Okay. So as a general rule of thumb, if you want to say that your lower bound here is negative 5, that should be fine. Usually, what I do is something like negative 100. It's unnecessary, trust me. Okay? But this is what I really want to focus on right here. What is this upper bound of our shading? The upper bound is negative 1.5. And now I want to do some cool crap. So you know what I'm going to do?
Menu.
I'm going to pick up a calculator. I'm going to hit that menu button. Yes, sir. Yes, sir. So I like to hear. All right, so you actually need a calculator page this time. So make sure you create a calculator page. Hit Control, Doc, or you can go to Scratchpad, either one. You don't ever need to save it, Lana. Okay, so you can also just hit, okay, I'll say you didn't have to create a
That's
new
the
doc.
way you showed me a few minutes ago.
So remember what you can do though, when you have a document, you just hit Control and Doc and it adds a new page.
What?
So you can do that. You want a calculator. Okay, so what button am I going to press to do cool crap?
Menu.
Menu. Let's go to menu. Any guesses where I'm going to go now to deal with this normal distribution?
Calculus.
Probability.
Statistics.
I'm going to go to statistics.
Please.
Anybody see any options there?
One.
What? Distributions.
Oh, there's a distributions thing. I wonder if there's anything fun under distributions.
Normal PDF.
Oh, go away. There we go. Not you. Normal distributions, normal PDF. Now, but there's also a normal CDF.
What does the P and what does the C mean?
So, the P stands for a probability density function. Okay?
never have yes there.
I know, right? Okay? So probability density function, what the probability density function does is it actually tells you how tall the graph is right there. That's not what I want though. I want all of this stuff, don't I?
Yes.
So it's CDF?
CDF stands for
Cumulative.
cumulative density function.
So what did you do?
So it's that one.
Oh, lower bound.
Lower bound.
What? Oh, you need a lower bound there?
Nine,
Here it is.
negative
Negative
9E999.
Yeah, that's
I'm pretty
crazy.
sure
Okay, so
it's
here's the
pretty
thing.
good.
Alright, so I'm gonna go to normal CDF. So what does that negative E999
I don't
mean?
even
A big
have
number.
it.
A very, very, very negative.
So that's just negative 9 times 10
Is it
to
bad
the
that I don't have
999.
That's
Is it bad? I don't have
No.
anything. I don't have anything at all.
Well, that's because you went to
Maybe it's a
inverse
big
normal,
number.
not normal CDF.
Technically, it's a really small number.
What?
oh really?
Whoever
Yes,
said it's a big
I don't
number.
remember.
Has a really
Because
large
it's Because it's
magnitude.
a negative, it's technically
Oh.
really small.
It is good.
But it is big, but it's
Nerd.
small. 'cause it's
Mr.
big.
Kennedy, I feel like you would do Excel competitions
Sorry, guys.
when you were in high school.
No, normal CDF.
I think I first.
I think
So
we did
hit the
this
number
one.
2 that helps prevent that issue.
Thank you.
Okay, so here's the thing, and this is what I will say. Once again, super negative number. If you even do negative 100, you're more than fine. Okay, but what's the upper bound going to be?
Negative 1.5.
Negative 1.5. What is that M thing down there?
Mu.
Yeah, it's not an M really. It's a mu, meaning
That's what it's supposed
that's
to look
my
like?
yes.
I've been making a weird looking image the whole time. It's
Yeah, I'm
like
terrible at
a
drawing
U
it,
line.
sorry.
Is it just a
It
straight
wasn't even
line
you,
up
I've been
and a
doing
U?
Yeah, huh?
Just a straight line up and a U.
Sure.
Yeah, I didn't know that.
Anyways, so what's my mean and what's my standard deviation?
That. Zero.
It's that, okay? So now remember, this is only because we converted to the standard normal distribution. Okay? So that negative 1.5 is the standardized score. We hit enter. And tell me this, what then is the percent of data that is less than 1.5 standard deviations below the mean?
0.0666.
Oh, say it again. Close to 6%.
6.6.
6.68%. What this is, and we need to be aware of this, what the calculator is kicking out is the area under the curve. The area perfectly connects to the probability that we're going to study. But as a percent, that's the percent. So that's the probability of a single person being at those values, but that's the area under the curve. If I ask for a percent, then you convert it to a percent. Okay? What's your question, Brayden? It looks like you're mulling over that. What's your question?
It's 6.68.
Uh-huh.
Is that like what's shaded?
So,
Yeah.
okay, so let me, have I talked to y'all about what area, I did talk about this, what area is underneath a normal distribution curve?
One.
An area of 1, right? So the area,
Oh, so it's 6.68% of that one.
well, but notice this is just,
Wait, what?
look, this is just the area 0.0668. So if I want to take that and multiply it by 100 to get a percent, it becomes 6.68%.
Yeah. Over
Oh.
the entire area, right?
Wait, now I'm confused.
Not that stuff is in
Okay, let's go back to our context to hopefully make this make more sense. What percent of the songs are shorter than 181 seconds? 6.68%
Oh, okay.
Yeah.
of the songs.
Oh.
We know that because the corresponding area on the normal distribution was 0.0668.
So that's of the that's of the shade.
That was the, no, that is the area of the shaded region.
Yeah.
That is the area. Okay. Okay. Because remember, the whole area is
It
just
is-
one.
yeah.
So you don't have to think it's this of that. No. That just is. Because my area is only one to begin with. Does that make sense?
Yeah.
So is that the Z-score too?
Well, this is the z-score. That's the percent.
The z-score is just not.
The z-score, so the z-score becomes the upper bound here, right? The z-score just tells us where it is in the distribution. What's your question? I hate to bring this up to you at a time like this, but I fell asleep on the couch last night doing grades.
You're a hard
No.
worker.
I think he's
Alright, that's
good.
a hard worker.
Were you on the clock while doing that?
Alright, say again.
Were you on the clock while doing that, or were you just doing it for fun?
No, I was working.
Did you get paid to do that?
No.
So then
I gotta do my job. Alright, let me show you all two things really quickly. So, by the way, what did we say? Oh, I do want to show you three things actually then. So first off, under probability, there's also an option for distributions. So you can go to probability or statistics for distributions. Okay, both will work. I do want you to notice, what was the actual mean for that song problem? The mean was, it was 220, right? So let's let my mean be 220, and the standard deviation was what, 226? Or it was 26, not 226. And then what was the length of the song, 181 seconds?
Oh, it's the same.
I'm confused. Is that not the same thing?
It is the exact same thing. Should it be different or should it be the same? It should be the same, right? Like all I did was standardize those scores. Now, hear me clearly on this, because I'm gonna go ahead, I just wanna get this out in the open. Students wanna do it this way all the time. You need to be comfortable and familiar with Z-scores for what we do later. Go ahead and standardize every single time.
Oh, okay.
Okay, my point is, these give us exactly the same. Go ahead and practice standardizing your scores every time. It will make your life easier in the future. Next thing I want to show you is this. Hey, what percent of our data is supposed to be between one standard deviations above the mean and one below?
68%.
68%? So there's one below and one above. And what percent's there? 68.3%, so 68%. What was supposed to be between two below and two above?
95.
95? What do we see? 95%, right? What about three below and three above?
Should be
99.
99.7?
So what are they doing to all these numbers?
So, what these last two numbers are the mean and the median. Or, sorry, the mean and the standard deviation. That's the lower bound and that's the upper bound. And the calculator is actually using calculus, Michael, to calculate the area underneath the curve.
Actually, I'm pretty happy right now.
So,
I got 90
Are those like
something.
integrals?
I'm like,
yes, integrals. Yes, when you study integrals, you will study how to find the area underneath the curve. But that's what the calculator is doing, is the calculator is using what it knows to find, or use calculus to find the area from here all the way up to here. So, by the way, I do want to point this out. So, do you have to know the empirical rule?
Well,
I mean, yeah.
No, I mean,
I mean,
this will work,
we
right?
have a calculator.
Yeah, but it's better to know it anyway.
But it is good to know the empirical rule, and more importantly, the empirical rule is quick and fast, right? 68, 95, 99.7, those are quick things that can pop into our brain and help us figure
Those
certain
two
ideas
things are the
out.
same, by the way.
Huh?
Quick and fast.
Thank you.
You're gonna use two things to describe something. Don't
Are
use
they the same though?
Quick and fast.
Just
Yeah.
use efficient.
So, getting back to the statistics here.
It's redundancy. It's redundancy.
I love
It's
that.
redundancy.
Alright, so number 6, Ed Sheeran and Beyonce made the list with the song Perfect Duet, which is 260 seconds. What proportion of songs are longer than Perfect Duet? Okay, I want y'all to work on this one together.
I got it